Hi, and welcome to this module on tables. This is the 10th module in the Fundamentals series, so please feel free to check out the previous modules if you haven't yet already. So far we've looked at atoms, lists, and dictionaries, and now the next level up of data structure from those is a table. And everything we've really learned up to now has been in preparation for learning about tables. They're the most important data structure in KDB, and they're where the vast majority of all data will be stored. So we'll be starting with an introduction to table discovery. Then we'll show two different types of tables. We've got unkeyed and keyed, and we'll learn about each of them and their differences. Then we'll learn how to create tables, how to access them, and then how to add data to them. Okay, let's get started. So before we do anything else, we need to run this initialization cell up the top. This is creating the tables we're going to need a little bit later on. And the notation here will be explained further down in this section, how to create a table. So don't worry about that yet. Okay, so before we query any tables in KDB, we first need to figure out what tables exist inside my process. And to do that, I can use this tables command with an open and close square brackets. And when I run that, you'll see I get 3 symbols returned, and these are my table names. And I'm just showing here that this is the equivalent as passing a backtick and full stop here. This is just saying return tables within my current namespace. So these two things return the same thing. Probably this one here you'll see more commonly, but this is useful obviously if you've got multiple namespaces set up and you just want to check the tables inside those. Okay, so next I might want to do something like find out how many records are inside my table, and we'd use the count command to do that. So if I count on 2 of these tables, so I'm just passing the table name here on the right hand side and the function count on the left, you'll see I have 3 rows in each table. So very small tables to start with. I also have this \a system command, and that simply does the same thing as tables up here. So we're just returning the table names. This is just showing you a variety here, a different way to do it. And then next I might want to do something like return the name of my columns in a table. So you can apply the keyword calls to your table. So similar to count, it's a monadic function, just takes one input, the table, and then you get the list of columns returned. So I've got 2 columns. So now that I know I've got 3 rows and 2 columns, I can safely say it's a very small table. So I'm going to call the whole thing into memory by running it with the table name. And you'll see here I've got my 3 rows and my 2 columns A and B. So this is useful. I can do the same thing with my complex tab because I checked the count of it up here, so I know it's small as well. And you'll see, yes, here I've got my 3 rows, and then I've got C and D returned, which are my calls. Now, do be very careful when you're running. Do be very careful using this. Do be very careful if you're using this approach to call your table. So do be careful if you want to use this approach. So do be careful. We wouldn't want. So this is fine when we have very small tables, but be careful. We wouldn't want to do this if we had a table that was millions of rows long and a lot of columns wide. So it's always a good idea to run count on any table before you try and retrieve any records or retrieve the results from it. So if the table was millions of rows long, what you might do instead is run the meta command. And what the meta command will return is our table schema and the associated metadata of that table. So where up here I got example and I got my columns up the top and then my rows down here, and you see it's separated by this line. Meta will return a summary of the table schema. So up here I've got 4 new columns. So C stands for columns. So you'll see that's my columns A and B here. So they're listed down here. So as many rows as you have returned from meta, that's as many columns as you have. And then I've got 3 new columns here on the right hand side. So T stands for data type, and no surprises here, this link will bring us to our data types on the reference card, which we've gone through in our other modules. So if I've got type J and S, I can go over here, look up the C column. So J is a long and S is a simple, and that's how I find out what types are available in my table. F and A here are blank. They're slightly more advanced concepts. than we'll be looking at in this course, but it is important to just know what they are. So F stands for foreign keys, and you can go here to learn more about them. And they're basically a way that we can establish relationships between tables. So if we wanted to have these two tables with a foreign key relationship, you would see that indicated here. And then A finally stands for attributes. And attributes are simply a way of tagging your data so that KDB will know how it's arranged before trying to do any lookup. And its primary role is to improve, and its core role is to improve performance. Okay? So you'll note that these are lowercase, and that means we have atoms within these rows. Now, if we have our complex table here, so if we run meta on that, you'll see my J in this example is uppercase. And we know from our list module that we have an uppercase returned. It means we have a list. We see that J is uppercase in this example. And if we go back up to these two tables, that's because within C here, now if we look at the second table, meta, on this complex tab table, you'll see for C, we have an uppercase J rather than a lowercase j. And the difference there is that for this first example here, we simply had atoms in every row, so just singular values, whereas C here has got two values, so this is a list. And this column is actually a list of lists, whereas this column here is a list. And that's indicated by this J. So that's very important to note, and that will come into play later on when we're trying to add data to the column as well. Okay, so have a go with this exercise. Very straightforward. Inspect the table definition and types for the key table example. So try that, and I'll see you in the next video.